Volcanoes Unveiled, the Science Behind Eruptions and the Catastrophe of Mount Tambora. Volcanoes, ancient sentinels of Earth's restless heart. They forge new lands, fertilize soil, inspire legends, and at times, unleash destruction on a staggering scale. But what ignites these fiery mountains? And what can the most powerful eruption in recorded history teach us about our planet's hidden forces? Join us as we journey beneath the surface to explore the science of volcanic eruptions, and revisit the catastrophic events of Mount Tambora, 1815. The science of volcanic eruptions. The story of a volcanic eruption begins deep beneath our feet, in the Earth's mantle. Here, intense heat and pressure turn solid rock into a molten, mobile substance known as magma. Magma is less dense than the surrounding rock, so it rises upward through cracks and weaknesses in the Earth's crust, pooling in vast subterranean chambers. Dissolved within this molten rock are volatile gases, primarily water vapor, carbon dioxide, and sulfur dioxide. As magma ascends and pressure decreases, these gases begin to expand, just like gas escaping from a soda bottle. If the pressure inside the magma chamber grows stronger than the rocks above, a rupture occurs, and an eruption is born. The style of eruption depends largely on the magma's composition. Magma rich in silica tends to be thicker and traps gases, leading to explosive eruptions, like those seen at Mount St. Helens. Magma low in silica is runnier, allowing gases to escape more easily, resulting in gentler, flowing eruptions, like those in Hawaii. Volcanoes are most commonly found along tectonic plate boundaries. At divergent boundaries, plates pull apart, allowing magma to well up and solidify, forming new oceanic crust. At convergent boundaries, one plate dives beneath another, melts, and forms magma that can eventually break through to the surface. Additionally, volcanic hotspots, fixed plumes of hot material rising from deep within the mantle, create chains of volcanoes, such as the Hawaiian Islands and the Galapagos. The 1815 eruption of Mount Tambora. In April 1815, Mount Tambora, standing nearly 4,300 meters high on Sumbawa Island in Indonesia, roared to life with unimaginable force. The eruption was so powerful that it could be heard over 2,000 kilometers away, a sound mistaken for distant cannon fire. In just a matter of days, Mount Tambora unleashed approximately 160 cubic kilometers of ash, pumice, and volcanic gases into the atmosphere, enough material to fill 70 million Olympic-sized swimming pools. Entire villages near Tambora were obliterated by pyroclastic flows, fast-moving currents of hot gas and volcanic matter that incinerated everything in their path. Estimates suggest that 10,000 people died directly from the eruption, while tens of thousands more perished in the aftermath from famine and disease. The eruption injected vast amounts of ash and sulfur dioxide into the stratosphere, forming a global haze that reflected sunlight and cooled the planet. The result was a dramatic drop in global temperatures, an event now known as the year without a summer. Thank you for joining us on this journey into Earth's fiery heart. Stay tuned for more explorations into the forces that shape our world. Don't forget to like, subscribe, and hit the notification bell to follow us into the next chapter of Earth's epic story.